So when we approach a new problem, what we want to do is we want to look at it and try and figure out what are they asking for, and then say, okay, of the pathways we've looked at, what's the pathway that's going to help me there, right? So when we've been talking about energy, we've talked about Q equals MC delta T problems, and now we've done some energy stoichiometry stuff. So easy clue at the beginning, I see a reaction, good chance there might be some thermochemical stoichiometry, which sounds scarier than it is. Man, I'm getting bags under my eyes. How old am I? So anyway, I read the question. It says, how much energy can we get from burning a 20-pound propane tank, right? So I read that and I'm like, well, they're talking about how much propane we have and they're asking about energy. So this is stoichiometry kind of thing, right? So if you're a little bit good at this, maybe pause and try and work ahead there. Otherwise, when you get to a point where you can do it, that would be a good idea to do. So I look at the problem and I say, well, I could do, a mole bridge for every 1 mole of propane, it's 2,220 kilojoules of energy, right? So this is a propane tank for your barbecue. So I could do the mole bridge there, but this is in pounds. So in my head, I start thinking, well, what's my pathway to get there? And I don't have to know the whole pathway if you haven't done tons and tons of these. But I think, well, pounds isn't great, but I could change pounds to kilograms, and then I could probably maybe molar mass in there somewhere, and then do a mole bridge kind of thing, right? So I just start thinking the path, but I don't have to have all of it in my head at once. So the first thing I'm doing is just make this into something more useful, right? So I say pounds to kilograms. How could I do that one, right? And I don't want to be dependent on just begging the internet to tell me on stuff, right? So we remember that on the back of our periodic chart, there's that nice little 2.2 pounds is 1 kilogram. So I could just do 20 pounds and say, well, I want pounds to cancel out. So 2.2 pounds is 1 kilogram. So 20 pounds is about, right, 10 kilograms. 9.1 is what we got for that, right? So that checks out with the estimation. My handwriting doesn't. So I've got 9.1 kilograms. So now I think, okay, I've got it in kilograms. I could do a molar mass step, but that's in regular grams. So I've got to convert from kilograms to grams. So just like from kilojoules to joules and stuff, right? Kilo, hecta, deca, base. So I move my decimal point 3 places. Or I just keep in mind kilo means 1,000. So it's 9,100 grams of propane. And eventually I want to get over here to kilojoules. And so it's starting to become a little more clear now, right? Well, I know I'm going to do this step in here somewhere, right? That'll be this last step because I'm going to energy. And so in my head, I've got a 2-step problem here, right? Some people like to put parentheses here to help separate them. That's fine, right? So I've got grams here. So I'm going to do the molar mass of propane down here. I'm thinking ideas and writing stuff down, so I'm not keeping everything in my head. I see a lot of students hesitant to write stuff down until they're sure. Well, as I put things down, if I put something in the wrong spot, I can fix that, right? For every 1 mole of propane, we do that. So now I just need a molar mass. Haven't done a ton of those lately. So I go back to my periodic chart and I see, well, carbon is 12.01 and there's 3 of those. Hydrogen is 1.01 and there's 8 of those. And I'm lazy, so I'm not going to bother to do anything in my head. I'm just going to pick up my calculator and do 12.01 times 3 plus 1.01 times 8. And that gives me a 44.11 grams. Don't multiply these two together, right? We add those two together. Multiply the subscript by that, but then we add the two together. Then I can go to my equation. Now, if it was oxygen that we were talking about here, right? The mass of oxygen, I do a 5 ratio down here at the bottom, but since it's propane, it's 1 mole of propane for every 2,220 kilojoules of energy. So this is going to be a big number, right? This is going to be like scientific notation-y big. So 9,100 times 1 times 2,220 divided by 44.11, right? Multiply by everything on the top, divide by everything that's on the bottom, and that gives us 475,000, right? So that's a lot of kilojoules right there. So I'm going to go ahead and put that in scientific notation. 4.6 times 10 to the 1, 2, 3, 4, 5. 4.6 times 10 to the fifth kilojoules, right? Or we could change it to megajoules, right? That'd be 458 megajoules if we wanted to do that, right? So that's quite a bit of energy. We could do something with that energy too, right? Like a Q equals MC delta T problem and say, well, how much could I heat up a tank of water with that, right? Because you can use, you can get a gas hot water heater and say, okay, well, how much hot water could I do with that, right? We'll do that in another problem, actually. That seems like a good idea.